Okay, so I actually made the classic mistake of forgetting to resume the recording after the break. But yeah, here I quickly go through what we did in the second part of the lecture after the break from the comfort of my office. Okay, so in the second part we wanted to we worked with creating subplots. So this is what I mean by subplot. You have one figure that comprises actually four smaller plots. So this is what I mean by subplots. This is useful for example, comparing different kinds of data sets. In this case, we are going to work with temperature data from the four seasons, and in this case, it's useful to be able to compare them. So that's the main point behind what we're doing. So as usual, we start by preparing the data, we import the data. Everything is the same as what we have done before, so nothing really new. One thing that we also saw in the first part, but I didn't open up, is this. So this means white space, and this plus means that one white space or more. And this is something we saw before, and it's just telling Python that it's treat this as raw text. Do not start interpreting this. So if you look at our data file, which we have actually here, you can see the columns are separated by spaces. So this is what we're using as the separator. So yeah, so let's just run this. We load the data. We rename one of the columns because the temperature is in Fahrenheit. So we rename it to F because we are going to convert it to Celsius as well. We have quite a bit of null values in our data, so I want to count how many. So you know that this is an A returns Boolean values, so 0 and 1. So if I start counting the sum, it essentially tells me how many missing values I have. And you can see we have quite a bit across the different columns in my data. So 1600. So I'm not going to blindly remove everything because I will lose so much data. Let's remove it, keeping in place true, updating the original data and counting how many columns we end up with. And as you can see, we end up with about 256,000 rows of data. So the data is quite large. We have talked about this before, but if you just blindly apply the drop NA on all of the columns, you will end up with a lot of rows removed. So you will end up with a very small, well, it's not very small, but compared to what we originally had, the data is very small, 6,600 rows. So we just limit the removal to the column with temperatures, not the min and max. And yeah, then we are going to calculate temp C from temp F, and this is something we have done many times, doing the conversion. Then we check the data to see if it has worked well, and the temperatures look right. So I think all went well. Now this is the fun part of creating the subplots. So as you might have guessed, to do this we have to create separate data files or data subselections. So I'm going to select winter, spring, summer, and autumn, applying a filter, doing a conditional selection based on the dates. So December to February is winter, spring is March to May, summer is June to August, and autumn is September to November. So quickly creating a plot of winter temperatures, summer temperatures. So these are individual plots, and now we are going to create subplots and put them into one figure. We want to work with data bounds more automatically. Of course, we want to apply the same bound to all four subplots, so they are a bit more comparable, because as you can imagine, the data temperatures from winter and summer and other seasons are very different. So if they're all in different bounds, it makes it difficult to compare them. So we just calculate one range for the extent of for the temperatures, then we just keep that one. So for that, I'm getting the minimum temperature of the minimum of every season. So the minimum temperature I have in my data is the minimum limit minus 5. So I'm adding a bit of margin to my chart to make it look nicer. Same with max. So maximum of all the maximum temperatures plus 5. Then I will end up with a range of minus 35 to plus 35. This is how you create your subplot. So it returns two things to you. So you have the axis, well, 4 of them in this case, and the figure, which is the figure as whole. So you can see that this is nested. You have nested, because you have rows and columns, we have nested subplots. So these are lists, so index based on, works based on index. So 1 0 0 0 1 1 0 1 1. So this is how you would access them individually. But because it's a bit of typing, it might end in some mistake, it's convenient to just rename them to something like this. So x11, x12, x21, x22. And then I will use these variables to access each of these subplots. So you need to access them, of course, to add the visualization and customize the visualization. So now let's do this. Let's create the subplots. You can see that I create the subplots again with 2 columns and 2 rows, specifying the figure size, renaming the subplots to something easier. Here I'm adjusting the line width, the thickness of each line, and this is what I do. So very similar to what I've done before, except that you have to specify which axis you want to add this visualization to. So for winter I go with x11, with spring x12, summer 2.1, and autumn 2.2. I apply a color that makes sense, so winter and blue sounds reasonable, orange in the spring, green in summer, and brown reminds me of fall, so autumn will be brown. I apply the same line width and the same Y limit to all of them. And then I will just run this. I will end up with this kind of visualization, as you can see here. It looks quite alright, but there are a few things I would like to improve. One is the title of the x-axis here. Change it to something more simple, more intuitive. And also I don't like these overlaps of the x-axis, the tick labels. So I will also rotate that so that it doesn't overlap anymore. Yeah, so I will make a few changes. So doing the same things, creating my subplots, defining the line width, visualizing each season one by one, and yeah, all is the same. This time I'm also adding a grid to each season, so grid is set true, so it will have a grid at the background. Another thing I'm doing, okay, so these are all the same. One thing I'm doing is adding a super title, so it's a main title for the whole figure as whole. So I'm adding title. Here is how I am rotating the ticks so they don't overlap so much. So I'm rotating it 20 degrees, and this will be rotating the label 20 degrees clockwise. So it will hopefully help us avoid the overlap. And then I'm also adding the label. So I'm adding annotation to the chart saying which season, each chart belongs to which season. So this is what I end up with for winter, spring, autumn, and summer. So I added the annotation, the label is fixed, the tick labels are rotated so they don't overlap with the lower one anymore, and that's it. Here we did a little practice how to create the same thing only for 2 seasons, so we ended up with 1 row and 2 columns, and everything was the same, and we also saved the image as a PNG file, and that was it. So next thing we are going to look at is effective plotting. So we looked at line plots, only working with one line. Now we work with multiple lines with imaginary data that is already typed in here, so we don't have to work with real data. So from some mythical cities, we have some imaginary temperatures from some old time, and we are going to define the data. So we run this, we convert it to a data frame. We looked at the contents using .head, and it looks fine. And next thing I'm going to do is to create a plot. So when you have multiple columns like this in your data, Matplotlib automatically creates a separate line for each of the columns. And this is how it is done here, you can see. and it applies a different color as the legend, which is nice. But remember that when you're creating visualizations, a visualization is more than a well, you want to also make it nice. You might want to communicate effectively with your visualization. So you want the user to be able to distinguish these lines well enough. And you know, some people are colorblind, for instance. So if you have combination of green and red like we have here, it might be difficult for some people to distinguish them. So one thing we are going to do is that, for instance, we are going to change the colors and add different styles to each line, so it becomes a bit easier to distinguish. And the way to apply different styles is by providing a list that goes in the same order as your columns, and you can here apply different styles. So with one of them I'm going with red dash, blue dots, double dash, green, and black and dash dot. And this is what you end up with. So not only have different colors for different lines, you also have different patterns, different styles. So even if someone is colorblind, they can still see the patterns quite well. So this is something to keep in mind. Next thing we talked about was the final exercise. So we have exercise 7, which is very similar to what we are doing this week, and the deadline is end of Monday next week, 20th of October. And yeah, so very similar to what we did today. And then we have a final exercise. For that you have to also again accept an assignment, but this time the template is quite empty, so there's nothing. You have freedom of doing what you want, so we will be working with an empty template. So one thing I forgot to mention about exercise 7, we have an auto grading, but it's not detailed because you're creating visuals, and with visuals it's hard to grade them automatically, so don't count on that too much. But for final exercise we do not have auto grading, and you will be working on data sets working with temperatures. So you will end up with a subplot like this, but you will be visualizing anomalies in temperatures, so you have to do some calculations and end up with this. It is okay to use AI, LLM, just do it in a reasonable way and make sure it doesn't make any mistakes. Still analyze what you get as the output, because I know it's going to make some mistakes for this exercise. And be transparent, so tell us how you have used it, how you have changed what you have gotten from LLM, and reflect a bit on your use. One thing that I would like to emphasize is, well, let me show you the grading. So this gives you an idea of what we expect in terms of what you should return. So with grading, of course, you do some data reading, you will process the data, do some analysis. We want you to use functions, and that will be part of the grading. You will do some data aggregation and then plotting. And with plotting is the technical side, of course, creating the plots, but also we care about the visuals. Like, do you make the plot actually work and make it aesthetically nice? At least put some effort into it, and that will be part of grading. One thing that I would like to emphasize here is documentation. So you're working with Jupyter notebooks. Of course, you can, to your code, add inline comments, add code blocks, comment blocks in your functions, for example, but also use the Jupyter Notebook cell to put titles and text and let us know what you're doing. This is important in a number of ways. Well, one, it's part of the grading criteria, so you get the grade for it, but also it helps us understand your code, because as I've said multiple times, the class is big and I'm going to grade, 70, 80 assignments. And if you have come up with some smart solution, I may not immediately understand what you have done. So to make sure I understand what you're doing, add a bit of comment, tell us what you're doing in each step, and then we will probably understand your code better and grade it more fairly. Yeah, so also we have been talking about good coding practices, so keep those in mind and create a code that is neat, easy to follow, and well documented. And that's all. Some of you will be continuing in the second period, where we will continue we will build on what we learned in this period and continue with GIS, and I will see some of you there. So good luck with your final assignment and enjoy your free week next week, and hopefully see you in other courses.